So for this week on CyberSchool, we're just going to do a quick talk about HTTP auto provisioning setup. We get a lot of questions about do your devices support provisioning? What methods can we use to set it up? What are the best practices for it? So I figured I would make just a quick little video that kind of just goes over the overview of how to set up HTTP and what it does for your products in terms of auto provisioning. But before we get into that, we really have to explain what auto provisioning is before we start setting up a feature that's going to use this feature. So auto provisioning is just a feature that's on CyberData devices and the majority of other VoIP devices that allow for automatic setup by downloading a file. And that's kind of the crystallized high-level view, what this thing does. You can get a lot more complicated and like actual explanations of the requests and everything that it does, but it's basically just a feature that allows the device to update its configuration file by downloading that file from somewhere. It's widely used across the telecom industry and pretty much industry standard when you're, say, moving to a VoIP provider, especially a hosted one, say like RingCentral or Zoom, or as an example, you don't get all of the phones that you're putting on all of your desks and set them up. You just plug them in and they magically work. Well, they magically work because they're using a feature like auto provisioning. It's one of those things that everybody does, but everybody has a different term for it. They call it a lot of different things. At CyberData, we call it auto provisioning. CyberData devices support multiple different protocols for actual file download itself, either TFTP, HTTP, or HTTPS, just secured HTTP, for getting that actual file from the server itself. And this is really, really awesome when you're trying to do a deployment, especially if, say, a lot of speakers and you're trying to set them up quickly. It'd really be a pain to go through the web interface of 100 some odd speakers and configure them all. Even if you're dealing with 5 to 10 devices, that can get a little cumbersome. And if you're doing with more than that, auto provisioning is definitely something you want to consider. But then it also makes device management a little bit easier in the future. Granted, we're not really going to touch on that for the purposes of today's discussion. So what is required as we get started with this? Well, of course, you're going to need a CyberData device, and you're going to need some kind of a server to actually upload the files onto. Today, we're just going to use an HTTP server because it's really easy to use with Apache. There's a variety of other ones out there that you can use, but for today's purposes, we're going to use an HTTP server. Next, you just need a configuration file, of course, what your device is actually going to download. Then you're going to need a PoE switch to power your device and some Ethernet cables. So with stuff like that, and a lot of that stuff, especially the PoE switch and the Ethernet cables, you're going to have that already. But I threw it in there just so that way that you've got everything that is required for this. So to set up your server, you're going to want to go through and install your HTTP server tool. That can be done on multitudes of different operating systems. Apache is, kind of open source and runs on just about everything. You can install it on Windows, you can install it on Mac, you can install it on Linux. For my demo, I did it on Linux because it's very easy to install via command line. You can still do the same thing on Windows, but then you have to deal with all the Windows permissions and the headache of the firewall. It's literally two lines in the command line on Linux to be able to install and set up Apache. So Linux is just easier to go through. And after you go through the setup process, you just want to go and prepare the file system and the directories on that particular server, because once the server is set up, it comes with a whole bunch of files that the device can actually go through, because Apache, when you think about it, Apache is a web server program that's used to host files on the web, typically for, say, like a blog, essentially, is what you can use Apache for. But it's basically just delivering a file there. So it's really easy to use as a provisioning server because you just replace all of those HTML files, your web page files, with all of your provisioning files. So that way the device just makes a request, gets the provisioning file, and sets itself up. And you just want to create your file system and any nested directories, if necessary, on there, just so that way it's a little bit cleaner for management in the future. So say, for example, you've got your /provisioning folder /CyberData, then you've got /Yay Yealink for all your Yealink phones, /Grandstream for your Grandstream phones, what have you. And you can just have everything a little bit more organized because all of our devices support nested file searching. So if you want to go and create a very nested folder system where, it is provisioning /CyberData /site name /building number, you can have all of that granularity if you really want to have your file system nested like that, where there are folders in folders. And then the final thing you want to do is just make sure the server is actually running as intended. That's really easy to do with Apache, and for when you install it in a Linux distribution, you just go to the IP address of that particular device that is running that Linux Apache system. For me, on my virtual machine, I just browse to the IP address of that virtual machine, and the web server pops right up. So that way you can just tell that, okay, my server is functional, it's serving up the appropriate web pages. That means my device will be able to download the file. The next thing you want to do is then just setting up the actual file structure and the actual CyberData files that are going to be downloaded by the device itself. CyberData devices, by default, anytime you boot them up and plug them in, they're going to search for two files. They're going to search for a file named 00000cd.xml, and that's going to be your common file. And that one is one that's going to be downloaded by every single CyberData device, whether it's an intercom, it's a speaker, it's a VoIP ZIP multicast speaker, it's a strobe, what have you. Every single CyberData product is going to download that specific file. But they'll also download a file that's going to be keyed to their MAC address. For the purposes of this discussion, I've just got in brackets there device-MAC-address, which is just kind of a placeholder for your device's MAC address. So every device will look for a file named with their specific MAC address. And that's going to make that device-specific file. And it can get confusing when you're thinking, okay, I've got a common file and I've got a device-specific file. What's the real difference between the two? Well, a common file is going to be used for one that's going to be settings that are shared across all of your devices. So for example, that would be things like, say, your time zone, because they're all going to be located probably in the same building. So they're all going to have that same time zone. For example, if you're on the West Coast, you keep it set to West Coast. If you're on the East Coast, you keep it set to the East Coast. But it's also a really easy way to set, say, volume for all of your different speakers. So that way, when you go and instead of having to make sure in your common file that you're adjusting all the speaker volume parameters that you want, say you want all of your speakers to play at volume level 7, well, you can just do that in the common file. And all of your speakers are going to download that common file. They'll set themselves to that East Coast time zone, and they'll set all of their volumes to 7. So it's just done automatically. You change one file and it affects all of the different speakers. Then for your device-specific information, that's where you're going to put all of the specific information that would be relevant to your particular device. So a key example of that would, of course, be SIP credentials, where you're going to get, say, a password and a username for a specific extension. For conversation's sake, extension 123, that's going to be unique to that particular device, because 123 is not 124 and it's not 122. It's 123. So each device is going to have that specific extension information in there. So extension 122 will have their own specific setup that will be keyed for their MAC address. Extension 123 will have their own, and extension 124 will have a completely separate one. So that way, when you're dealing with all of that, again, device-specific information, that can all go in the file that's keyed for their particular MAC address. So they're the only one that's going to get that. And then all of your common files, again, your volumes, your time zones, say your multicast addresses that you're using, that can all go in your common file because that's going to be shared between all of your devices. And that makes it really, really powerful. But one of the things that people can get tied up on is this two-file support. Okay, I have to have two files. Not necessarily. You can throw everything into your MAC address specific file, and you don't even have to mess around with that common file because depending on how you're setting up, that might be better. Or in some cases, you might want even more granularity. Say you might want to do it in more. Say you want to have your common file for your audio settings, and you want to have it for your time zone. You've got your device specific file for all of your specific extension related information. And then for the actual audio file stuff, say that you've got all of the different audio files that you can customize on a CyberData device changed into a different locale. Say you're installing these in Latin America and everybody speaks Spanish or Portuguese, and you want to change all of the actual audio files themselves to a different language, you can do that. And you can list all of these different audio file names in a brand new audio file, a brand new file that the device will download, a third file, and you can just list that file for it to download in the MAC address keyed file in the autoprov file section. So that way, when it downloads its device specific information, it says, oh, I need to go get a third file that is going to list all of the different audio files that I need to download, and so on and so forth. So if you want to have a lot of granularity and a lot of capability for specific devices to download specific additional files, you can do that. But by default, all of our devices are going to download 2 specific files out of the box, no matter what. That 00000 cd.xml and their MAC address keyed file. But to actually create the file, again, you're really just going to load 2. These are 2 examples of specific things that you might want for your common area file and your device specific file. You've got, again, your time zone and your volumes. That's usually shared across all of your endpoints. And then your device specific information is stuff like your SIP information and your multicast zones, because that might be specific to, say, a particular speaker or a horn, and that might not be shared between other endpoints. So now that you've got all of your file systems set up, you've got the actual files prepared and loaded on the device, loaded on the server itself, the last thing you have to do is set up your actual CyberData device. And for the demonstration that we're going through today, since I do all this in my home lab, I don't have the capability to set up fancy things like DHCP rules, which is a thing that you only get access to with business class routers, or if you deploy your own your own DHCP server, say on Linux or something. With a DHCP rule, you have the option to point to either specific FQDNs or fully qualified domain names or IP addresses using specific rules. Say if you want to point to an HTTP server like we are doing today, you use one rule, whereas if you want to say point to a TFTP server, you use a different rule. And that just helps the device when they go out and they fetch their IP address from this DHCP server and they check in there and they get their IP address lease, they check which of these rules, if any, would be applicable to them. And if there's anything listed for these different rules, they go out and check at that particular server. And this is really awesome for big setups where you don't want to have to log into the device at all, and you just want to be able to literally take them out of the box, plug them in, and they're going to set themselves up. DHCP rules are the best way to do it, because when the device boots up, it gets its IP address, it sees that one of the DHCP options is configured, they go to the IP address that's listed there, and they download the file. Bing, bang, boom. Super duper easy like that. In my network setup, because I've got a regular home router, I don't have that capability, and I haven't gone super nerdy and set up my own DHCP server. I have to do everything manually by actually logging in to the device itself and going to the auto provisioning tab. Not the end of the world to do that, but it's a physical step that you would have to do for all of those speakers. And if you're deploying 100, DHCP rules would be the best way to go, assuming you have access to that with the DHCP server that you're using. But to just go to the Autoprov tab is not a big deal. You just log into the device and you go to the Autoprov tab. And then for this specific setup, you just use the simple string that I have listed in there for the auto provisioning server, HTTP ://192.168.1.17. Then we've got :80, which means it's going to make the request to port 80 in the directory /provisioning/CyberData. And all of our devices by default will add an additional trailing slash to the end of that actual server field. So our device will actually look for files in that provisioning/CyberData/ directory. And by default, as we covered earlier, it's going to look for 2 files, one keyed with its MAC address and a 000000 cd.xml file. So it's going to look for those 2 files, and if they exist, they're going to download them. And they do exist because we just loaded them in there. So it's a really easy way to go through the actual provisioning process on our devices. It's quick, easy, and simple. So The next thing that you want to check, of course, did it work? And how do you go through checking that? Well, depending on the server that you're using, especially say in a Windows environment, you might actually have logs on the server that'll say, okay, this device contacted me at this time and, requested this file. I served this file and the file transfer process finished at this time. That's really common with things like, say, TFTP servers, but you can also get that with different HTTP servers. So that's one first place to check. The next place to check would be the actual auto provisioning log on the CyberData device itself, and that's on that auto provisioning tab. And you can just see, okay, did we make contact with the server? Did it download a file? See what it says there. Another way to check is, what files should have been changed if the file was downloaded, and see if any of those settings changed on the device. Because by default, since our factory is in Monterey, California, we're going to ship on West Coast time. So if you're on the East Coast and you change your time zone, if it's still showing the West Coast, it might not have downloaded the file. But if it's showing East Coast, it probably downloaded the file because that's not where California is. Another good key one to look at is the registration status with the phone system. Commonly, when you're going through the auto provisioning setup, you're going to be also including your SIP credentials. And when it downloads the file, it should be automatically registered with the phone system. So those are some different ways that you can actually check and verify that, after you went through all the process of setting up the HTTP server, creating the files, loading the files, setting up the device, did the thing actually work? Was that time all well spent? Well, these are a couple different ways to actually go through and check and make sure that that actually worked. So at the end of the day, is all of this actually worth it? It's definitely a little bit of work to get everything set up initially. For, somebody that knows Linux or, knows how to set up one of these servers, you can do it in 10 minutes. But for the average person, it's probably going to take you a little bit more time, maybe 15, 20 minutes to go through the process of setting everything up and loading in your files, and then, at scale, it might take you a little bit longer. If you're deploying and setting up, 100 different specific files, it's going to take more than an hour, just to prepare all of those different files. So, that's one of the things to think about there is, how much time it actually takes and is it worth it for this kind of setup. But it future-proof stuff just because it gives you that capability to manage everything from that particular server. But one of the things that makes this really, really worth it is it makes it a really easy way to deploy multiple devices at once and not having to install them and then log into all of them and set them all up. If you use a HTTP server or what have you in DHCP rules, you can literally plug and play the devices and get them as close to a toaster as you want. And it makes the installation absolutely a breeze. But, if you're working in some different scenarios and you might not want to use, say, an HTTP server, you're afraid that it's not encrypted, you can use HTTPS. Or if you don't care about security at all, you could do TFTP. So with that wide support of protocols, it makes it really, really easy to go and pick an option that's best for you and best for your network setup. But with all of this kind of cool capability, since we're just using open source software like Apache to go and load onto a server and, actually go and create the file hosting, you can do this on AWS or, multiple other file hosting systems to be able to do this, say, as a reseller. And if you're deploying CyberData products to a whole bunch of different locations, you can easily create your own provisioning system that can be hosted in the cloud. And you don't necessarily have to take a laptop with you and plug that in and have all your files ready there and use that as your server. You can throw it up in the cloud and it can be joestelecom.com/provisioning, and you can set up all of your equipment from there. If you want to go and do something like that. So auto provisioning is a super powerful feature of CyberData devices and is really easy to set up.
Thank you for watching this edition of CyberSchool. If you have any questions, please get in contact with our sales department. They are available by email at sales@cyberdata.net or by phone at 831-373-2601 extension 334. Please make sure to like this video and subscribe for more content like this from CyberData.